Okay, so here's the second part of that section. We have two problems left to do. So we'll take the partial derivative with respect to x. Still the same thing, find the extrema. So we get 4x plus 2y plus 2. And we'll take the partial derivative with respect to y. So we get 2x plus 2y. Alright, so this isn't as easy as the other ones rather. So we just got to see what we can do. We have 4x plus 2y plus 2. We're going to set that equal to 0 to solve it out. Just moving it around for a second, that's going to give me 4x plus 2y equals a negative 2. Now looking at the other derivative that I have, 2x plus 2y equals 0, to find the critical numbers, I set it to 0. So what this gives me here is a system of equations. Now, you can solve a system of equations by a whole host of ways. You could use Cramer's rule, or you could use substitution or addition method. It doesn't matter, but you do have to find a point that solves both of these equations at the same time. So what I prefer to do is the addition method. So solving this by the addition method, I'm going to take this second row and multiply the whole thing through by negative 2. Now my first equation is 4x plus 2y equals negative 2. Let's leave that one alone. And my second equation would be negative 4x, negative 4y equals 0. So I can add these up, and this would be a negative 2y equals negative 2. So that means that y equals 1. Alright, so I have y. So to go back and find x, I can take that y, 1, and plug it into any of the equations. I'm just going to pick this top one. So this would be 4x plus 2 times 1 equals negative 2. So 4x plus 2 equals negative 2. So 4x would equal negative 4, and x would equal negative 1. So my critical point for this one, is negative 1, 1. Now, I don't care if you use the addition method. I don't care how you solve it. It's just a basic system of equations that you had in Algebra 2 in high school. Use addition, use substitution. However you get that point is fine with me. Now then, I have to determine if that point is a max or a min. So we go back and take our second derivatives. So fxx is going to equal 4. And fxy is going to equal 2. Fyx is going to equal 2. And fyy is also going to equal 2. So my determinant is 4, 2, 2, 2, which would be 8 minus 4, which is 4. So D is greater than 0. I also know from the top that fxx is also greater than 0. So since they're both greater than 0, that means that negative 1, 1 is a min, relative min. Alright, so we have one more of these left to do. This is number 27 from your textbook. It was a little different than the others, so that's why I chose it. So you have the partial with respect to x, so that would be 4x to the third minus 4y. Okay, and my partial with respect to y would be 4y minus 4x. Alright, so solving this one's going to be a little bit more troublesome. So if you look at this top one, remember we're going to set it to 0. Now, if they were both x's, that would be easy. You would just factor it, but they're not both x's, so you can't factor it. Looking at the second one, you have that 4y minus 4x would equal 0. Well, that changes things up a bit. So look at that second one. So if you're looking at the second equation, we can actually solve this out by substitution. So on this bottom one, I can rearrange it and say 4y would actually equal 4x. Divide both sides by, just moving it over, of course. Divide both sides by 4, and y would equal x. Now then, y equals x. That's important. So if you go up here, remember y equals x. So let's just keep it with blue. So you have 4x cubed minus 4y, but remember y equals x. So I can put that there. So I'm going to get 4x cubed minus 4x equals 0. I'm going to factor that. They have a 4 in common, and they have an x in common. So that leaves me with x squared minus 1 left over. Now that continues to factor. Difference of squares. Set this one to 0. Set this one to 0. Set this one to 0. Now, that means we're going to have 3 different critical points. So you'll say, well, what's the y value? If you look right here, remember that y equals x. So if I plugged in 0, I would have 0, 0. This would be 1, and y is also 1, and this would be negative 1, 1. So I have 3 critical points. Now, I don't know if they're maxes or mins or saddles. I don't know what they are, but I know that I have 3 critical points. Okay, so going back over to this side, when I take the derivative with respect to x, I'm going to get 12x squared. When I take this derivative with respect to y, I'm going to get negative 4y. So, sorry, just negative 4. Taking the derivative of that with respect to y, the first piece would be nothing, and taking the derivative of negative 4y would just be negative 4. Alright, so then we have fyx. So taking this derivative with respect to x, we would get a negative 4. Taking the derivative with respect to y, we get 4. Alright. So D, your determinant, would equal 12x squared, negative 4, negative 4, 4. So that would be 48x squared minus 16 equals 0. So just double checking your signs. Your main diagonal here would be 48x squared minus your second diagonal here is a positive 16. So minus a positive 16, that's how it would look. Now, I don't care how you solve this one, but we're basically, you don't have to solve it because we're not, it shouldn't be set to 0. Sorry, that was a mistake. I was like, it looks like it should solve, but it doesn't solve. This is D. That's what's important. That is D. So what we have to analyze is D at these 3 points. So let's find D at the point 0, 0. Okay, so if you plug in 0, x being 0, into this function here, you're going to get a negative 16. So if D is negative, that means you have a saddle point. So you have a saddle point at 0, 0. Okay, so let's analyze what happens at D at the point 1, 1. Okay, mainly when x is 1. So when x is 1, you're going to get 48 minus 16, which is 32. 32 is greater than 0, so we need to keep looking. Okay, 32 is greater than 0. Now, go back at the top. We also need to know what happens at fxx. Well, fxx is 12x squared. Okay, so if we have 12x squared and we're plugging in 1, that's just going to be 12. So that's also greater than 0. So that's not D though, sorry. fxx is greater than 0. So if D is greater than 0 and fxx is greater than 0, that means at the point 1, 1, you have a relative mean. Right? So that was the second one. Let's get the third one. Sorry about that. Here's the next one. So you have D of negative 1, negative 1. Now notice up at the top, that should be a negative 1, so we need to fix that. I know that was driving some of you crazy. Sorry. If we plug in negative 1 into this blue D determinant formula, we get 48 times negative 1 squared, which would be positive 1, minus 16, so we still get a 32. And what I know about 32 is it is positive. Okay? So we also have to see what happens at fxx. Well, fxx is still 12x squared. And even though I plug in negative 1 into that, I'm still going to get a positive result. So D is positive here again. And so that means I have another relative mean at negative 1, negative 1. Now, you can say, well, how do you have two minimums? But remember, they're relative minimums, not absolute minimums. So they are the minimums when compared to points nearby. And so that's why you are allowed to have two minimums. Okay, so this is a min, and this is a min, and this is a saddle. And that's how that one would look.